Hi guys, my name is Kyle Vincent Tango and today I will be reporting about data compression. So, without further ado, let's proceed to my topic on research, namely entitled The Mathematics of Image Compression, the Big Picture, a Stepping Stone Towards a Finer Quality of Digital Life. Topics to be discussed under this research are namely a brief introduction and history of the topic, types of compressions, own-made examples and calculations, how mathematics is involved in the topic, significance of mathematics in image compression, and overall summary of the discussed topic. Before we proceed to what really an image compression is and what it is all about, let's first have a brief history of image compression. So ever since the start of 20th century, throughout the course of digital evolution in this time of moments, many technology experts want to expand their mathematical thinking and are innovating technology to its finest purpose, specifically for improving image quality and reducing its file size, making it the so-called high-tech because images have high pixel values, resolutions, and other contributing factors which makes it hard to compile all in one storage, thus making the computer so lagged that other files need to be removed in order to boost the computer. And so, at the start of this century, one of these experts named Samuel Morse developed the Morse code and used it in the telegraph. He noticed that the codes have different frequencies, which means other codes have higher frequency than others. And so he devised a way that for the codes with higher frequency should have shorter sequences, while for the codes that have lower frequency, thus should have longer sequences. And one of the jump start point of the development of image compression was through the information theory developed by Claude Shannon. And in later years, further enhancement and development with his partner, Robert Fano, but unfortunately, they were surpassed by David A. Huffman because of his the Huffman algorithm technique, which is the enhancement of the Shannon-Fano algorithm. And so years later, after so many researches, so many experimentation, so many testings that have done throughout the course of the history of image compression, and until now in the 21st century, it came to life and bringing about a lot of good changes in today's technologies and improving the digital life quality. So I found this quote by Maureen Howard: I like density, not volume, signifying that content of pictures are more essential in a way that compressing the data should still remain with the same of its original version despite losing some of the file's area with the same pixel value. The mathematics behind image compression has been a big aid in today's technology in a way that it improves the computer's functionality at an outstanding level. This research tends to provide a knowledge and an appreciation for image compression and the math behind it as one of the biggest factor contributions on how it can lead people to live with the latest technology upgrades for maximum optimization of digital life. What really is an image compression? So image compression is the reduction of file size to allow you to store multiple images in your device storage. Image compression gives a lot of benefactors in terms of saving file space, such as significantly boosting the device's memory and loading speed. Images have several ways of being compressed. Many of them have different processes, yet most likely they are to give two results, namely the lossy compression and lossless compression. The lagging of device systems are usually a cause of redundant files building up, and this is where lossy compression comes to work. Lossy compression is a type of compression that occurs when you compress a file and remove some parts of it, including its redundant files. Yet the outcome of the image is still the same. Lossy compression is widely being used in ordinary images, video files, and audio files. Thus, its reduction ratio is bigger compared to lossless compression. While on the other hand, the lossless compression is where you compress a file in which no other files are removed. Lossless compression is accurate in terms of reproducing the encoded file into a new one. However, it's most likely limited to a compression factor of 2 and 3 to still achieve desired image outcome. They are usually used in personal records such as school files, business files, exclusive image, and video contents. So this pictures or this image was taken directly from my phone, which has an initial resolution of 1341 by 1433 and an initial memory size of 304.63 kilobytes. This is the lossy compression version of the original image, and it was edited from my phone using the app Photo Compress and Resize. So this file size was reduced to 87.28%, which made the initial memory file size of the original version of the image very small, that it was compressed to 16.16 kilobytes. And if you can see, if you notice that the image here presented in this slide is very blurred, because this is a lossy compression, redundant files are removed and making it very blurred because it has higher reduction ratio. Last but not the least is the lossless compression version of the original image, which is also edited from my phone using the app Photo Compress and Resize. This was reduced to just a very small amount percentage of memory size. That's why its final memory size became 186.73 kilobytes. As you can see, or if you notice in this image, that its resolution is somehow similar of the original version of the image, because this is a lossless compression, thus making its redundant files kept, and it has lower reduction ratio compared to the lossy compression. As a summary of my own made examples, so here's the comparison. So if you can see the original version of the picture, of course it's the most clear of all. Then going to the lossy compression, which is the most blurred, and from the lossless compression, which is what I am saying in the previous slide, which is somehow similar to that of the resolution of the original version of the picture. So in the lossy compression, it has higher reduction ratio. That's why it's more blurred than other images, and thus it has very high compression factor. What does compression factor mean? Compression factor is uh, the ratio of how much you compress an image. So the bigger the compression, of course, it will be very proportional to how will you be able to perceive the image, if it's very blurred or not. Now, going to lossless compression, it has less reduction ratio, no data loss, low compression factor, and it's very less blurry than others. This is this is a this is an example calculation that I made it on my own based on my research. So let A be the image resolution pixel count, meaning to say the area of the whole, or rather the area of the whole resolution of the image. So let B and C be the dimensions of the area of the image. So this is where mathematics is having its own stepping stone towards being involved in data compression, or specifically image compression. So as you can see in this image, that this is a rectangular shape, meaning to say that it has length and width. So using the simple laws and formulas of simple geometry, that the area to find the the area to find for the rectangle is length times width. So given that the length is 263 and 271 pixels respectively, to calculate its area, just multiply the length times width. So 263 pixel times 271 pixels is equal to 71,273 pixels all in all. might be wondering how mathematics is further involved in image compression by just other than simply calculating some simple geometric ideas. So, furthermore, if you hear the word data compression, specifically image compression, it may sound simple. But the bigger question is, how do they do it? This is where mathematics comes in. So much theories found by using the laws of mathematics, such as my example in the previous slides, which needs to solve to get significant values that needs in order to compress images. In relation to the information theory by Claude Shannon, he formulated three mathematical theorems specifically for data compression. As you can see, how the programs for the data compression are in phones are actually the integration of all the formulas and theories from the past, including the algorithms developed. So if mathematics is involved in image compression, therefore, it correlates to being significant in the said topic. So based on my research, I've seen that math is the only concept that paved way for the advancement of data compression, specifically for images. The development of theories and formulas are what gave these technological experts the need to research, experiment, and analyze with the new hopes of modernizing and improving image compression. Mathematics is what made them correlate one variable after another to create substantial laws in order to correct and detect errors so that the compression of image when encoded will be as it is, as decoded after passing through the channel. From the generation of old age to the present, the math behind image compression allowed technology to provide people an improved quality of digital life and can possibly lead our innovation of technology to ideal and futuristic ones. So here are some website references that I used on my research.